Students, good morning to all of you. Yesterday we studied about addition of vectors and we have explained you how we can add vectors. One rule was explained yesterday. There was triangle of addition of vectors. So what is triangle of addition of vectors? When two vectors are lying in a plane, these two vectors can be added using triangle law of addition. In this case, these two vectors can be represented by the two sides of a triangle taken in order. Right? Taken in order means you will take these vectors and fix that vector as the side of a triangle. Then other vector is kept at the head of that the previous one. That way, these two vectors can be considered as the sides of a triangle, right? Taken in order. That all these things I said, right? Then the third side taken the reversed order will be the resultant of the two vectors. I told you one thing that vectors cannot be added, subtracted, or multiplied by using simple methods of algebra. There are special rules for that. In that direction, I have explained the first one, addition. That the first rule is addition of vectors using triangle law. Triangle law is explained. Now we are coming to another rule for addition of two vectors. That is parallelogram law of addition of vectors. It is written here. Parallelogram. Actually, this I made a parallelogram. Right? Parallelogram law of addition of vectors. So how this could be understood? When two vectors are acting on a body, for example, two forces are acting on a body, you suppose that in a plane surface, there is an object O is placed here, and it is tied to two ropes. One is along this direction, other is along this direction. And the two people are pulling it with the two forces, one is P and other is Q, right? P and Q are two forces, right? These two forces are applied on the object at O. Then you will see that the very interesting thing you will see that the object can neither move along the direction of along OA or along OB, but it will move along OC. The direction in which the object moves is the direction of the resultant force acting on the body. So P and Q are vectors. Vectors means, in this case, I am taking these two P and Q are forces. And at this place, on a plane surface, on the table itself, we can keep an object and tie it with the two ropes separately and pull it, making an angle theta. Then you will see that the object can neither move along OA nor move along OB, but move along the direction OC. So what is OC in this case? This OA and OB can be considered as the two adjacent sides of a parallelogram. And the parallelogram is completed, then OC will be the diagonal of the parallelogram. So this is the theory. So when two vectors, in this case, I'm not using the word force, but I am using vectors. Force is a vector only, right? So when two vectors are acting on a body simultaneously, then these two forces can be represented by the two adjacent sides of a parallelogram. And the resultant of these two vectors in magnitude and direction can be represented by the diagonal of the parallelogram, right? Suppose along OA, the vector is P. Along OB, the vector is Q. Then resultant is acting on the diagonal of the completed parallelogram. That is what is called a vector R. What is vector R? Vector R is the resultant of P and Q. That is why we are writing vector R is equal to vector P plus vector Q. Right? In triangle of addition also, the thing is same only because all are same. Right? Suppose this is a triangle. Which triangle? OAC is a triangle. Right? In a parallelogram, you must understand one more thing is that the parallelogram has two sides, two pairs of equal and opposite sides it has. These two sides are equal in magnitude and opposite, and parallel. And this also parallel and equal in magnitude. If this is Q, this also is said to be Q. So if this is P and this is Q taken in order, then the third side, what is called OC taken in the reversed order, will be the resultant of the two vectors. Right? Same thing. If this is the triangle when you are taking, that is OBC. OB is Q already, you know, and BC is equal to P because OA is equal to BC in the parallelogram. Opposite sides are equal in magnitude and parallel. Right? Therefore, P and B, sorry, vector OA and vector BC are same. So in this triangle also you can see this one. P and Q is OB, vector OB, and this is vector OC are taken in order. Then the vector OC taken in the reversed order will be the resultant of these two vectors. In that case, we can write vector R is equal to vector P, vector Q plus vector P, vector Q plus vector P. So you will know that vector P plus vector Q is equal to vector Q plus vector P. This is another rule characteristic of vectors. That means vector addition follows commutative law. That also explained here, right? This is called parallelogram law of addition of vectors. Once again, the definition: when two vectors are acting on a body simultaneously, then these two vectors can be represented by the adjacent sides of a parallelogram. Then resultant of these two vectors can be represented in magnitude and direction by the diagonal of the parallelogram. Yes, this is the condition, right? So here we can say that, here we can prove that the vector R, that means the resultant vector R is equal to vector P plus vector Q, right? Okay. Now the magnitude of the vector is also explained. Magnitude of the vector, that means modulus vector R. Modulus vector R is equal to, modulus vector R is given by simply R is equal to P square plus Q square plus 2PQ cos theta also we can write. So this is the resultant magnitude of the resultant that can be obtained from this diagram, right? This is a parallelogram, and this side we are extending up to D, and from C a perpendicular is drawn. Now there is a triangle you see that is equal to ODC, triangle ODC. In triangle ODC, what is AD by AC? So what's AD by AD by AC, that means base by hypotenuse. So this part when you see, if this angle is theta, this also will be equal to theta, right? Am I correct? This is corresponding angles. So this, right? Okay, this is the condition. So this angle is equal to theta, then naturally this also will be equal to theta. This is extended and this is the perpendicular. A small triangle we are getting here, that is a right angle triangle, right? Yeah, we have extended it, that's all, right? Okay, this side is a bit extended and a perpendicular is drawn. So a right angle triangle is formed here. From this right angle triangle, we can calculate AD is equal to AC cos theta. AD is equal to AC cos theta because cos theta is equal to base by hypotenuse. Base by hypotenuse. Base is AD and AC is what is called hypotenuse. You are getting AD. The value of AD is calculated in Q cos theta. Also from the triangle is this triangle sin theta is calculated. Sin theta is equal to perpendicular by hypotenuse. Perpendicular CD by hypotenuse is AC. Therefore, we can write CD also can be calculated. CD is equal to AC sin theta. AC is equal to Q because this is equal to Q. OB is equal to Q. Therefore, AC also equal to Q. In a parallelogram, opposite sides are equal in magnitude and parallel. So if this is the vector Q, and this also can be considered as the vector Q only. In that sense, CD is calculated as Q sin theta. Right? Now, you take this big triangle. We actually want to calculate the resultant of resultant OC. Vector OC is the resultant, right? OC, vector OC is equal to vector R. Therefore, magnitude of vector OC is equal to magnitude of vector R. So we want to calculate magnitude of vector R. So vector R includes in this triangle. It's a triangle OCD, this big triangle. So in this big triangle, OCD, that means the square of the hypotenuse. This is 90 degree, therefore this is the hypotenuse. This big triangle you will see, it is a right angle triangle. Which a triangle? OCD. In triangle OCD, OC is the hypotenuse and OD is the base and DC is the perpendicular. Am I correct? So by Pythagoras theorem applied for this right angle triangle, we can write the square of the hypotenuse. Square of the hypotenuse is r square, right? A square of a vector is always square of the magnitude only. Remember that. Square of a vector is equal to square of the magnitude only. That's what simply r square written. Never write vector r square. No. Simply r square is needed because square of a vector is square of its magnitude. So r square is equal to this side is what? OD square plus this side is what? CD square. But OD is equal to OA plus AD square plus CD square. Am I correct? Okay. So this is extended. That means there is expanded. That is OA square plus 2OA into AD plus AD square plus CD square we can write. So when I am applying the values of AD and CD, right? OA square means OA means P square. 2 into OA means P into AD is equal to Q cos theta. That means P square plus 2 into P into Q cos theta plus AD square. AD square means 2 square cos square theta plus CD square. CD is equal to Q square sin square theta. Understand? So this is how we can calculate the resultant value of the